Hi students, welcome back to Vijay Datta chemistry classes. This is your Purnima Mam. So today we are going to start types of reductions part 2. Part 2 in the sense, see, in the last video we have done with chemical combination reactions, chemical decomposition and displacement reactions, right? Today we are going to discuss double displacement reactions, disproportionation and comproportionation reactions. So without let us start enter into the double displacement reaction. So I am going to the fourth type of redox reaction, that is double displacement reactions. So these double displacement reactions, ma, see, these are very double in a single displacement. Only one metal has been displaced, right? Here double displacement, two metals. Suppose see here, I'll take one example. I'm taking the acid HCl. I'm taking at the same time I'm taking the NaOH, means base NaOH. It is a reversible reaction, ma. Whatever the HCl I have taken, it is an aqueous solution, and even NaOH also aqueous solution. So the product immediately it will be the NaCl plus H2O. See, NaCl is the salt, H2O is the liquid will form over here. See, it is also aqueous NaCl only will form, even it is also in the aqueous solution. Not only this, ma, we can go for the another type of the reaction. That one, see here, any double displacement, even though they are salts also, the double displacement should takes place. Okay, comes to this example, it is a strong acid and it is a strong base, both are reacting to each other and displacing sodium in the place of sodium hydroxide hydrogen, and also in the place of hydrogen sodium, both are displacing to each other. So in the double displacement reactions, generally we'll study two types of reactions. First one is the neutralization reactions. Again in double displacement, two types, neutralization, and the second one is the precipitation reactions. These two are come under the double displacement reactions, students. So neutralization reaction is nothing but acid and base reacting to each other, forming a salt and water. Those reactions are called neutralization reactions. Even how they will form displacement here, double displacement in the aqueous solutions, that is what I have taken. So immediately they dissociate into ions. H become H plus, Cl becomes Cl minus, Na plus, OH minus. Then they'll displaces the ions, then it comes to the Na plus and Cl minus. So these are called ionic reactions also, ma. Generally whatever the reactions we have, those are two types: molecular reactions and ionic reactions. These also I discussed in my previous videos. So this is the, so the ions are displacing, so these are called neutralization reactions and double displacement reactions. Comes to the precipitation reactions. Precipitation is nothing but, see here, see, I'll go with the uh, AgNO3, means silver nitrate reacting with the barium chloride. So whatever AgNO3 I have taken, it is the aqueous solution. Example, right? And BaCl2 is also an aqueous solution. Then the reaction will be reversible. Then I am taking this AgNO3 dissociates just like as Ag plus and NO3 minus nitrate ion, might is barium chloride Ba plus 2, because it is the second group element, so its charge is plus 2. Whereas come to the chlorine is the seventh group elements, its charge is minus 1. So to balance we'll take 2 Cl minus ions. That is the another thing. So after this they dissociates. Az comes and reacts, form groups into the Cl, and then Ba comes to this side and it forms. So whatever here it is forming AgCl plus barium nitrate BaNO3 taken twice. Whatever the AgCl is formed here, that AgCl is the precipitate. Downward arrow represents the precipitate, and also it is a white color PPT. So by displacing you are forming the precipitation, those are said to be precipitation reactions. By displacing we are forming the salts, those are said to be the neutralization reactions. Both will come under the double displacement reactions only. So this is about the double display, and obviously we can say it is an redox reaction. Always double displacement reactions are redox reactions only. Az plus, see here, Az plus NO3 minus Ba2 plus and Cl2 minus, this the double displacement is taking place over here. So these are the redox reactions. Now come to the next type of the reaction. Mm, uh, fifth type of the reaction, disproportionation, which is very, very, very important, because all these types of four types of reactions we'll study in lower classes. Whereas come to here, this disproportionation is very important. That one we are going to study here, right? So the next fifth type is called disproportionation reaction. Disproportionation reaction. See, in this disproportionation reaction, what is this? This definition I want to write completely because important it is. A redox reaction in which the atoms of same element, in which the atoms of same element undergo both oxidation and reduction. Oxidation and reduction is known as disproportionation reaction, student. Disproportionation reaction, student. So here it is the disproportionation. So I want to explain this one with one example. See here, I'll go with the one of the example, that is Cl2, means I am taking the chlorine plus 2 moles of OH minus, I am taking a balanced equation. Then it forms ClO minus and also Cl minus plus H2O. So whatever Cl minus is formed here, it is in the aqueous solution. And also here dilute, we are taking some base, some different conditions. But here see, chlorine, what is the chlorine's oxidation state over here? uh, Chlorine's oxidation state is 0 because it is in elementary state. Obviously, OH is nothing but OH minus. Otherwise, you can get the complete reaction. You can take NaOH also. Comes to here, ClO minus. The charge is for complete. So you want to know chlorine's exact oxidation state, right? So to know the chlorine's oxidation state, imagine it is as the X. Then ClO minus. You want to know. Then it is X, then oxygen we are taking as usual -2, only one we have is equals to -1. Then x equals to -1 plus 2. Then x is equal to +1. So in this, chlorine shows +1 oxidation state. Oxygen shows -2. That's why overall charge is -1 they have given. Comes to here, this chlorine having the charge which is called -1. Hydrogen is +1, oxygen is -2. Right? Okay. Here see, in this OH also oxygen will be -2, hydrogen is +1 ma. So what we understand from this reaction, oxygen is -2 in the reactant side, even oxygen is -2 in the products side also. So there is no change in oxidation state of oxygen. Comes to the hydrogen. Hydrogen here it is +1. Even in the product side also hydrogen is +1 only. So there is no change in oxidation state of hydrogen and oxygen. Now come to the chlorine. Whatever the oxidation state of chlorine in the reactants side, 0. Chlorine's oxidation state is 0. So see here, this chlorine shows +1 in one case, and again the same chlorine showing -1 in one side. So from 0 to +1, so increasing oxidation state is called oxidation. The same chlorine -1, decreasing oxidation state is called reduction. That is what disproportionation reaction means. The same element undergoes oxidation, undergoes reduction in the given chemical reaction. Such type of reactions are said to be disproportionation reactions. Got it? So same element undergoing oxidation in the product side, undergoing reduction in the products side. That is called disproportionation reaction. See, whatever the reaction we have taken here, it is the dilute cold conditions, ma. Dilute and cold conditions. So you can take concentrated and hot conditions also for the reaction. One more example with the same chlorine. Then what happens? So you have changed chlorine you are taking, but whatever the base we have taken, that base is in hot and concentrated you are taking, then it gets, see, actually I am taking the balanced equation because our concept is not balancing here, that's why I'm taking directly the balancing equation plus SC, see here, yeah, Cl minus, it will be 5 moles plus H2O, it is producing the water, right? So I'll write its physical states also. Cl minus is the aqueous solution and H2O is the liquid state. Okay, whatever the chlorine here I am taking, that is the gaseous state, and also OH minus is in the aqueous state I am taking. Okay guys, so let us see here. So again chlorine is the oxidation state is 0. Same oxygen is minus 2 and hydrogen is plus 1 over here, isn't it? Hydrogen is plus 1 over here. Comes to this reaction, ClO3 minus, you want to know. So minus. So here chlorine is X plus oxygen is minus 2, like that we have 3, which is equal to charge we have minus, so it is minus 1. So X minus 6 equals to minus 1, X equals to plus 5. So what is the chlorine's oxidation state here? It is plus 5. Again oxygen is minus 2 only. Here chlorine is minus 1, they have given. H2O, hydrogen is plus 1, oxygen is minus 2, right? So there is no change in oxidation state of hydrogen and oxygen. So what is changed here? Chlorine again. Chlorine oxidation state is 0. So it has converted to ClO3 and it has minus, and it has converted to Cl minus. In ClO3, chlorine's oxidation state is plus 5. In Cl minus, chlorine's oxidation state is minus 1. So from 0 to plus 5, oxidation. From 0 to minus 1, reduction. So in the same 0 to plus 5, hot and concentrated. Dilute and cold conditions, 0 to plus 1 only. That is what I want to explain. So same chlorine is getting oxidation and reduction in the products side. So so these are said to be the disproportionation reactions, student. Okay. Now let us see, students, these are very important. Sometimes they'll ask, they'll give the reactions, and they ask which is the disproportionation or not, with this is comproportionation or not, either it is a double displacement is correct or not, such type of questions they asked. Okay, this is also very important topic in mains, advanced, and need point of view, right, students? Okay, let us move to the next type of redox reaction, that is comproportionation reaction. I think you know by listening the disproportionation means decomposing. So in the products side, comproportionation means reactants side, combining reactions. Okay, comproportionation reaction, comproportionation reactions. See here, in the comproportionation reactions, what is the definition we can say? In these reactions, two species is definition. So two species of same elements, two species of same element, sorry, same element with two different oxidation states, with two different oxidation states, with two different oxidation states from a single product, and also forms the single product, forms a single product, means reactants side 2 we are taking, but it is forming the products side is 1. So forming a single product with an intermediate, with an intermediate oxidation state, with an intermediate oxidation state. Okay, so it is reverse of disproportionation. Exactly, it is the reverse of disproportionation. Okay, students, let us see this also. I'll go with one example and I'll explain just it is the opposite to the disproportionation. First, let us see in the disproportionation what happens. Reactant side is single oxidation state has been decomposed, splits into two oxidation states like reactant side 0 is there, that splitted into plus 5 and minus 1 like in the products side. Means decomposition has been taken place. That's why these are called disproportionations. Whereas come to the comproportionation, reactants side two oxidation states will combine and gives only the single oxidation state on the products side. Means see here, Az plus 2 plus Az gives rise to 2Az plus. The oxidation states are here, sorry, the physical states are aqueous state, it is in solid state, and it is in aqueous state. Okay, let us see here. Az plus 2 already they given here, it is plus 2 oxidation state. It is in elementary state, its oxidation state is 0. Comes to here it is showing plus 1 oxidation state. So plus 2 2 plus 1 plus 2 to plus 1 decreasing oxidation state reduction, 0 to plus 1 increasing oxidation state oxidation. So reactants side two different oxidation states forming the single product with the same oxidation state, that is called the comproportionation. You see here it is a comproportionation. If I give the arrow this side, it is the disproportionation. Means the single oxidation state is decomposing into 0 to plus 2. If the two oxidation states are comproportionating into plus 1. So this is called comproportionation reaction, which is very, very, very important. They can ask the reactions, they'll give what is disproportionation, what is comproportionation like. Okay, students, so this is the stoichiometry and mole concept. Most of the part on the mole concept stoichiometry I have been covered. And also here balancing the balancing the equations are there. Actually, while we are preparing for the NEET mains and advanced aspirants, the balancing the equation is not a subjective to write the each one part and one part, right? So we need to do, so it is a hit and trial method workouts very easily. So they'll give four options with the whatever the coefficients he is asking, just substitute which option is balancing you, that will be the option. Okay, anyway for the subjective preparing students also, plus one plus two aspirants also, I'll give you in some other video. Okay, but in the next video I am going to start atomic structure till the advanced level students. So for the NEET mains, MSET and advanced aspirants, my videos will be helpful, no doubt at all. So I am going to start atomic structure in my next video. Stay tuned, please do subscribe to my channel. Please subscribe my channel and please like, share and press the bell icon to get the notifications from my Vijay Datta chemistry classes. This is your Purnima signing off.